All right, here we go, guys. Last video of the term. We're talking about conditional probability. So conditional probability is kind of this expression over here. We read it as the probability of A given B, and we interpret this as what is the chances? What are the chances A happens given we know B happens. All right, so what are the chances A happens given that we know B happens? And there's a formula for it here, and we'll see a couple different ways to calculate it in a little bit. Another thing we can do is we can actually use this to tell if two events are independent. If we think about it, right, two events are independent if one happening does not affect the probability that the other happens. So if this definition should make sense because if I want to know what's the probability A happens that I know, given that I know if B happens, well, B happening doesn't matter if A and B are independent, so this will just be probability of A. Right, if they're dependent, B happening will change the probability of A, but if they're independent, B happening will not change the probability of A. And then finally, we have this general multiplication rule, which says, how do I calculate an AND probability? Well, it's probability of the first guy times the probability of the second guy given the first guy, right? And if these are independent, right, it actually just reduces to our rule from before, because if A and B are independent, this is just the probability of B based on our rule over here. All right, so this is the general multiplication rule. Three rules we can use going forward. Let's do some conditional probability using a two-way table here. So if you remember how to read a two-way table, this row is all the people that survived. This row is all the people that died. This is all the first class, second class, third class passengers, and just the outsides. I guess I can do it in here and in here. These are our totals for our columns, and this is the total number of passengers. Right here's the total number of passengers on the Titanic. Okay, so we define some events. We got F is first class, S is a survivor, T is a third class passenger. So A, we want the probability of T given S, which is the probability or the chance. Is the chance a survivor was in third class. Okay, it was a chance a survivor was in third class. So there's just two different ways of calculating this. We'll use our formula first. So our formula is probability of T and S divided by, if we go back here and look at our formula, divided by probability of S. All right. So probability of T and S. So for both of these, maybe I'll write the second one in a different color. We'll do that maybe. Futz with this a little bit. Make that black. And make this purple. Probability of S. So probability of T and S. So what we're going to do is we're going to divide by our total number of passengers, 1207. And what's the number of people that are in third class and survivors? Well, it's 151. So there's a numerator for our fraction. And the denominator is the probability that you're a survivor. Well, there's 1207 total people. And how many of them are survivors? 442. Right? And if I were to simplify this, we would get 151 over 442. But there's actually a different way of doing this as well. It gives us the same answer. We want the chance of survivor was in third class. So another way of thinking about that, this is given that I know I'm a survivor, what's the probability I'm in third class? So I only live in the survivors. So I start with how many survivors there are. That's my denominator. Since we want to know the probability that I'm in third class, given that I know I'm a survivor, and there's 151 people in third class. So there's two different ways of getting. There's a different way of getting that answer. Okay. All right. So now then again for question B, which I'm kind of running out of room here. We want to know that given our person was not in first class, what is the probability they're a survivor? So we want to know it's a probability. So this is B. It's a probability question. We know they're not in first class. F is first class. So we're given that they're not in first class. We want to know what's the chance that they're a survivor. Okay, so we want to know, given that they're not in first class, what is the chance that they're a survivor? All right, so we can do this kind of in both ways we did above, but I think the easiest way is the Brown way again. So given that we're not in first class, so we need to figure out the total number of people that are not in first class. So that's 261 plus 627, which is 888. If I added that right, these two numbers. And how many survivors were in those two things as well. So I need to know my survivors in these two things as well. So it's 94 plus 151, which is 245. So there's our probability for that one. All right, and we could use our formula again if you want, but that's probably easier in this case. Okay, and let's look over here. Look at this next problem. I'm telling us the probability of someone being male given that they have a pierced ear is 19 over 103. And let's make sure we can make sense of that. Probability of people that are male given they have a pierced ear. So there are 103 people that have a pierced ear. How many of them are male? 19. So it's 19 out of 103, which matches with what they got there. All right. So now we'll do the same thing. We want to check if two events are independent. And if you remember, we can check if two events are independent if probability of A given B is equal to the probability of A. All right, so let's do it. Probability of A given B. A is male, B is pierced ear. Oh, we calculated that right over here. Probability you're male given you have a pierced ear. So that's 19 out of 103. And is this equal to, what is it? It's the probability that you're male. A is male. So there's 90 males out of 178 people. So this is 90 over 178. And we'll notice that like this is less than 0.2. This, what I'm highlighting here in green, this is less than 0.2. And this guy that I'm highlighting now in red, this is bigger than 0.5. So I don't actually know what the numbers are, but I know they're not equal. So these events are not independent. not independent because those two values are non-equal. All right, and we'll do it here again. And we want to know if the events male and left-handed are independent. So we want to know if the probability of male given left-handed is equal to the probability of male. Okay. And what is the probability of male given you're left-handed? Well, there's 10 lefties and 7 of them are guys. So 7 out of 10. And is this equal to the probability that you're male? Well, there's 100 people. There's 100 total people, and 46 of them are male. So no, these are not equal numbers, so not independent. All right, and what you guys have to do is there's a bunch of problems here, works through some of this kind of same stuff, and that'll be that. Good luck.